Welcome to BeeGraphy. Learn how to create a wavy wall with a repeating pattern using parametric design in the cloud. See how BeeGraphy simplifies complex shapes with easy-to-use nodes. The video shows the process of creating a 3D textured structure in BeeGraphy, a powerful 3D modeling program. We will create an image that we will call waved lines. Here we get an image that looks like a series of woven metal strips. It almost looks like a modern metal fence. Our journey begins with the ever-useful range input node. This important tool allows us to define adjustable parameters for our design. We will call it height and give it the minimum 100 and maximum 150 values. Next, we use a toConstruct point node to create precise points in 3D space. By setting x, y, and z coordinates, we can place points exactly where we need them. This second point helps define the span and shape of our wavy lines. We've set our start and end points, and now we'll use the Curve Editor node to create the wavy shape. This tool lets us draw and adjust curves directly in the 3D view, like a digital pencil. We can add points, move them, and change the curve between them. Now that we have 2 points, we need a path for them to follow. The Connect with Curve node connects the points and places the Curve Editor between them. This allows us to create straight lines, arcs, or more complex curved paths. But in this case, we need a straight curve. That's why we will make the circles in the Curve Editor into squares. Next, we'll closely examine the node's coordinates, allowing us to precisely control its appearance and make detailed adjustments for a customized look. Next, we add some movement to our design by rotating the curve. The Rotate node lets us rotate any shape around a specific point and axis at a set angle. To control the rotation angle, we'll use the Degtorad node. This node converts an angle value from degrees to radians. With the rotation of our curve completed, we'll now introduce a translation operation using the Move node. This node offers the capability to move any 3D geometry along a specific vector. For our purpose, we'll utilize vector y, and to fine-tune its movement, we'll integrate a range input node, which we'll name thickness. Now, we will use the Line SDL node to create the basis of our design. This node allows us to create a straight line segment by defining its starting point, direction, and length. To focus on the next steps and maintain a clean viewport, we can hide these initial curves. To create symmetry, we'll use the Mirror node. This node mirrors any input geometry across a chosen plane. We'll use the plane YZ node, which represents a fixed plane perpendicular to the x-axis, dividing the space along the YZ plane. Next, we add a construct point that will serve as the defining boundary of our mirror work. Furthermore, we'll include a range input node called Length, which will allow us to dynamically control the position of this construction point along a specific axis. Now that we have our mirror waveguides, we can combine them into a single flat surface. The Loft surface node does this by taking 2 or more curves and creating a surface between them. The Extrude Curve node takes a curve and stretches it along a chosen direction, creating a surface. It pulls the curve along the path, forming a smooth surface with the curve as its edge. In this case, we'll use the vector x end and give it the length we got earlier. After extruding the curve to create a surface, we use the Move node to shift it in space. This node moves the surface along the vector z to set the height of the image. To enhance visual clarity and streamline our workspace, we will subsequently proceed to conceal those nodes whose presence is deemed superfluous or potentially distracting. Now, let's add a twist to our wall section. Bring in a rotate node and connect the joined surface to its geometry input. Before we create multiple copies, let's place our curved wall section. Add another Move node after the rotate node. Next, we'll add a vector x node to move it in the x direction. ND to set the transfer size, we will add length and 5 with an addition node, where 5 is the distance we chose from one to the other, and length is the length of our image. Now it's time to multiply our curved wall section. Add a linear array node and connect the output of the Move loft surface and extrude nodes to its geometry input. Linear array is a powerhouse for creating repeating patterns. It takes our existing geometry and duplicates it with a straight line. In this case, we add the vector x. We can easily control how far apart they should be spaced. To control the number of these elements, we add a range input node called count. This lets us adjust the number of elements as needed. We use the Apply Material node to give the surface a realistic look. It adds color, texture, and other visual details. In this case, we'll choose a plywood material to show its natural grain. The node lets us adjust the material's color, roughness, metallic look, and opacity for full control over the wall's appearance. Now let's activate the demo from the menu to the right and see our model. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.